And I am live. That is nice. Today is 19th of October 2025, Sunday, and today we will do event looping, and this is going to be crazy. Why do we need event looping? We need event looping because so that we can, our server is fast. We need event looping for speed. That has been my interpretation of why we need event looping, because threads are slower. And yes, event looping is scalable. Using threads for every connection that we get is slow. And also the other methods which we saw yesterday, there was thread and there was making a new process for every connection. For every client connection is also very, very slow. So yeah, we should not do that. That is pretty bad. But what we can do is use event loop. What is an event loop? Event loop finds the clients which are ready for reading or writing and just reads and writes to those ones, like first to the ones which are ready. And event loop does not wait for any client to get ready, or like for any buffer to, or any socket is the better word, for any socket. If our process wants to write to some socket and there are a bunch of sockets, then event loop will find the socket which is ready, to which we can write, and then write to that socket instead of just choosing any one random socket and trying to write to that, because that socket might not be ready. Yep, that is event loop kind of. And today we are going to implement it. So that is like even cooler. My voice is audible and yep, things are pretty cool. Write the echo server from chapter 4 into an event loop. What was the echo server? Echo server Yeah, the echo server in chapter 4 was, I guess, a normal server. Yo, it was not a normal server, it was request response protocol server, in which we had our own protocol where the first 4 bytes are going to be in little Indian representation, the length of the message, and then the following bytes are going to be the message itself. Now, this is the pseudocode. While the server is running, we have a list of sockets where we want to read, and a list or array or vector of sockets where we want to write. And then we call some function and we pass in both the lists, and we get the socket where we can write right now, and we get the socket where we can read right now. Or not a singular socket, but all the sockets where we can read, and all the sockets where we can write, and then read to all the ones where we can write, where we can read from, and write to all the ones where we can write to. Makes sense. Application code versus event loop code. Okay, some libraries can abstract away the event loop. The event loop code interacts with the application code via callbacks. All of this is crazy. All of this is crazy. So who is doing the callback, and what the application code is the only code we can write. So there is another thing called event loop code. Okay, so some libraries can abstract away the event loop. The event loop code interacts with the application code via callbacks, and the application code interacts with the event loop via well-defined API. We are not writing a library, but there is still an implicit boundary between the event loop code and the application code. So they mean to say, hello. Nope, I didn't give that, but I saw that Omnic uploaded a video in which he was solving questions which were there in the Meta Hacker Club. So that is crazy. That is cool. Per connection state. Okay, so they mean to say in this thing that event loop code is handled by some other code and our application code is separate. What does that mean? Wait, I guess before going to ChatGPT, we should read some more. Within event loop, an application task can span multiple loop iterations. An application task can span multiple loop iterations, so the state must be explicitly stored somewhere. Here is our pre-connection state with an event loop. Okay, an application state. Okay, before getting into event loop, let me like explain why, because I thought it is not necessary for me right now. I want to learn more things like this. I didn't thought it is very necessary, and I can give it maybe next year or whenever I want later. So yeah, I don't have to rush and give every hackathon that is out there. Yep. And yes, let me first put forward what my interpretation of a event loop is. So what normally happens, normal normal function is we have a list of sockets. Let's say, yep, a list of sockets, and let's just talk about one operation, which is write operation. And yeah, socket 1, 2, 3, 4, 5, 5, 6, 7, 8, a bunch of sockets. And here we have our application code, our process which is running right now, and this process goes to the first socket and writes to this socket, but the buffer which is attached with this socket might not be empty, right? It might already be full, and therefore we cannot write to this socket right now because there is no space to write right now. So what would happen normally if the function call is non-blocking is that our call or write call on this socket, it will wait till there is some space in the buffer of this socket, and when there is some space, then our write function will write to the socket, and then our process will move on to writing something on to the next socket. And this is bad because when we were waiting for this socket to get some space so that we can write on its buffer, maybe there was this socket which was already in a state so that we can write to it. So instead of waiting for this socket number 1 to get ready, we could have switched to this one which was already ready. So in event loop, this is what happens. Like, this is what I think happens, my interpretation. In a event loop, we have again a bunch of sockets, a list of sockets, 1, 2, 3, 4, dot, dot, dot. We have a bunch of sockets, and at a time, we will pass this whole list to some function, to some like abstract function, and then this function that we have passed this whole list to, this will return another list, and this list only contains the functions or only contains the sockets which are ready for reading or writing, whatever we want to do. Yep. So whenever we go and write to a socket which is in this returned vector, we don't have to wait. There is no waiting. We are simply writing. There is no waiting for this socket to get ready because these are all the sockets which are ready. So I think that is event loop, because we are only the event of getting ready when a socket is ready, that is a event, and when a socket is ready, only then we loop and we write or do whatever we want to do on that socket. Event loop is more of a general concept. It is also used in game development where it is more times called game loop. So saying that event loop does this would be kind of wrong technically. Yes, I'm just making not shit up, but mm, improving my interpretation. So thank you for this. Event loop is more of a general concept. It is also used and I'm basing off my views on what was there yesterday. Sure, I guess I should have read more on event loop specifically, but I was like writing Rust. Hello, is your laptop back? Event loop, okay. Yeah, event loop, how I learned to master JavaScript's event loop. No, understanding event loop and concurrency. Beginner's guide, JavaScript. Why are they all about JavaScript? Let's tell ChatGPT what I think is happening, and it will correct me. That is like one of the best things that AI has given us. How are you handling multiple connections? Well, yesterday we did this thread server. Yesterday we wrote this code, and this is bad. Like whenever there is a client connection, we are creating a new thread, and on that thread we are handling the client, and we are detaching the thread, and this is not very scalable. This is what the guide said, that this is not very scalable. Yo, shit. And of course, I got into a fight with the compiler immediately. Yes, shit. But Rust compiler is much better than C++ compiler because it tells you exactly what is wrong. Yeah, major lagging. Thread is bad. And this is still kind of mysterious for me. How are we like getting more speed without using threads? That is crazy. That is literally crazy. And judging on this pseudocode, nope, this is not the pseudocode. This one. Here we have a list of sockets where we want to read, or and a list of sockets where we want to write. And we are calling a function, pseudocode function, and we are giving in the list of sockets where we want to read and write from, and we are getting a list in return, and these sockets are the ones where we can immediately read from and write to. Like these are ready, we don't have to wait for them to get ready, and then we are reading and writing from and to those sockets. So that is my interpretation, or like, of a event loop, and I think that is kind of right. Yeah, wait, Rust, yeah, C++ doesn't tell, it is, the error is very abstract, but Rust is pretty cool. You can create a multiple mutable pointer to a mutable variable. Okay, it stopped working at a time near, so I am getting frustrated now. Shit, that is crazy. What exactly happened? If it was a software problem, then you could boot Linux. That would be crazy. You could create a mutable pointer to a mutable variable, but cannot use them both simultaneously. You cannot print the original variable until the lifetime of its. Okay, I don't know about lifetimes. I just wrote Fibonacci sequence in Rust. Of course, some shit decided to implement print as a macro, which takes variable by reference and gives error. Shit. Just do this, okay? I suppose you are going to send a bit of code now, and I did a few questions yesterday, not few, two exactly. Submissions. Oh, shit, Dominator 69, the army of tester. Look at this. Rust. First try. That is good. And Rust is actually faster. And the way that we have to read variables, look at this. Okay, let me show you the speed test. Create a variable and create a mutable pointer to it. And what is this? That is crazy. Create a variable and create a mutable pointer. How? Okay, I don't even know the syntax. It is stopped charging, and I don't have Linux. I have Windows. Shit. You should have Linux, I suppose, and try printing the variable value and its pointer dereference. It will throw error. So you mean create a variable and create a mutable pointer to it. Okay, and then try printing the variable value by pointer dereference. It will throw error. Wait, it will throw error? I do conceptually get the thing, but why would it throw error? Yes, I'll do it right away. But before that, look at this. This was C++ code, and this took 77 milliseconds. And look at this. This is very simple. C++ makes sense. We are taking in a bunch of numbers and then we are giving out the answer. And then we have the Rust code. C++ took 77 milliseconds, and this one took 46 milliseconds. But the code, I think there might be some better way to take in input. Look at this. This main function itself is very big. So here I'm reading a string first and then read line into that string and then parsing the string into a integer I32 and yeah, that thing, and here also. But here, since we have multiple numbers on the same line, we have to split, collect, and get each individual number separately, and that is all crazy. Print both in one line. Writing Rust is somewhat like Java syntax wise. This is all crazy because you can only create one mutable reference and cannot print original values until it is mutable variable stays in the scope. Okay, let's see. Let's see. I mean, see, not let's see. And hello.rs. Okay, we have something. How do I create a pointer? I don't even have a LSP running, so wait. Permission denied is crazy. Programming languages. Okay. FN test doesn't do anything. And here we have let x equals I32 equals some number. Yes, we are going way off the topic, way away from event loops. Is the concept of ownership and borrowing, and how is it possible to yep, crazy concepts. How is it possible to literally both use same backend of LLVM? So the optimization is literally the same. Rust technically just a LLVM wrapper. Technically, because yes, both are using LLVM permission denied on your own laptop. Yes, I cannot even CD into. I guess because Bash does not have permissions somehow. Yeah, I guess Bash does not have permissions. That is why something like that. And yes, that is a good question. I guess because C++ or G++ is not using the full capabilities of LLVM. Okay, do that in your free time. That should be better. Yep, because this very, but this is very interesting. This is actually pretty interesting. I mean, of course, yes, the Rust is interesting. Tmux attach target missed. Yep. Cool. And yeah, this thing is bad where we are creating threads and detaching threads, and we have to detach the thread because when the loop runs again after, like, if we don't have this line, then after this line when we are creating a new thread and the loop runs again, since this is an object destructor, the destructor for this object my thread will be called, and yeah, destructor would be called for this, and the thread would terminate without actually handling the client. So we have to detach so that even if the main thread goes out of scope, this thread cannot be terminated. It is still running. That is cool. New incomplete. There is a update. And yes. So we will move forward with this definition of event loop, where we are calling some function, and this is just pseudocode. So the main function is a bit different. And if that is the case, what do they mean by event loop code? And what do they mean by application code? I suppose by event loop code, they mean this function, wait for readiness, and this function, and all of this other thing, rewrite echo server from Z4 into an event loop. Okay, let's read more. With an event loop, an application task can span multiple loop iterations, so the state must be explicitly stored somewhere. Here is our pre-connected server thing. Yep, they were created by Chris Latner. LLVM was literally made for it, for optimization. Clang was created by the same guy, organization who created LLVM, so I doubt you won't know full capabilities of LLVM. I'm using GCC, so I don't know. But yeah, shit, yes, that code was executed on code forces using GCC. And well, shit, I haven't thought about this because you are correct. They are using the same internal structure, LLVM, and there is a, I think, intermediate language. The front end part has to be written by the specific language writer, compiler person. Like for Rust, we have the front end part, and the back end part is what is handled by the LLVM. And LL for shit, the thing is like this. We have LLVM, Red LLVM, a Dragon LLVM, and LLVM does like do binary conversion and optimization. This is what LLVM does, and this is same for different compilers. And what changes for different compilers is, for example, Rust. We have the Rust compiler, Rust C. Rust C has a front end, and what this front end does is it takes the code. Yep, shit. That is our code, which is written in .rs. This front end takes the code and gives the code not directly to the LLVM backend, but converts the code, the rust.rs code, into a intermediate representation. And this intermediate representation, IR, is defined by the LLVM project. And yeah, if you want to make your own compiler, all you have to do is take the source code of your language, parse it into tokens, or however you want to do it, and convert that into this intermediate representation, and you can leave the rest to LLVM. LLVM will take this intermediate representation, optimize it to the fullest, and create the output binary. This is the front end, your REST compiler, and this is the backend. That's how you use LLVM. Async is better because you can only create so much threads, whereas with async, you just take the user call function and move to the next user. Okay, but who is then handling these things? Yo, hello. If the original variable is not mutable, then how can you create a mutable pointer? I guess by a mutable pointer, it means that the variable to which the pointer is pointing to, you are not mutating the variable's value, but you can point your pointer to some other variable. I think that is what mutable means in this mutable pointer context, not that you can change the value of the variable to which your pointer is pointing to. Hmm. All of that is crazy. It is pretty chunky. LVM very bloated. I came very close to actually know about its bulkiness while I was writing my own language. Okay, and you are in your drop year. That is crazy. Shit, that is crazy. Writing your own compiler code, crafting interpreters is a nice book. Okay. Yep. So this is the definition of event loop that we are going by, and I still don't understand what you mean by async here. Like my process is the only process which is running. So who else is running? The binary of my process is the only binary which is running, and if I'm not creating any threads and not creating any processes, then who is going to tell me that a process is ready? Because my binary is the only binary that is running. I guess this will make more sense as we read more here. With an event loop, let's tell ChatGPT. ChatGPT knows my name. Shit, data privacy. Privacy is gone. Uh, Event loop is the concept where an application to handle, wants to reduce the the total time that it is waiting for some external operation to get ready. For example, in a server, the server might want to write to some sockets, and yeah, and if the server were to take any socket from the list of all the socket which it wants to write to, the socket might not be ready to be written to. The socket might not be ready to be written to, and if the write wall is blocking, then the main thread will be blocked, since it will wait for the socket to get ready and then write to it instead in an and if we were to create a new thread for every socket that the server wants to handle, then if you were to create a new thread for every socket that the server wants to handle, then it would be uh, also low. First, there would be a lot of overhead because of context switching, and each thread have its would have its own, not one, each thread would have its own stack, which is not very memory efficient, which is not very memory efficient. And also, these threads technically are only running, technically are only running on the same processor and not same. And yes, and also, yes, this is a subtle point that I want to like get through. Asynchronous programming, mutable pointer, literally what it says, mutable pointer has the permission to change the original variable it points to. Shit, is it the pointer that is mutable or the variable that the pointer is pointing to that is mutable? Like, these are two different things. You might have a constant pointer or a pointer to a constant variable. Yeah. Okay, and so you are saying this is the definition. Okay. And I don't know right now. I've not read a lot of Rust. And also, yes, this is a subtle point. Since also, and also these threads are running on the same processor and thus not technically running at the same time, and thus if any thread is trying to write to some non-ready socket, it would still result in wait. And here we are supposing that we do not have multiple cores, and if even if we do have multiple cores, each process or threads belonging to a same process won't be running on different cores. That is what we are supposing, and that might technically not be right. Okay, anyways, the point is that using threads is not bad, and the main thing with this is what is event loop. Event loop is better. It is better. Conceptually, is a function call which takes in a list of sockets or FDs which we want to write to, and returns a list of the FDs which are ready to be written to. That is nice. That is just what event loop is, I suppose. It's like suppose, okay, you take the customer's order and pass it to one the one making the coffee in the kitchen, and you move on to the next customer. Now, when the coffee is ready for the previous customer, have you seen Harikat's video? Maybe that will help your doubt. Okay. It is delivered to the customer via the counter. It's like calling the same function many times with different values, like how you create a add function and call it with different values. Yes, but we only have the main thread. In JavaScript, we have node. Node is a separate process which is in real time running the JavaScript process. So there is a parent process, and JavaScript thread can tell the parent process, run this function for me, I'm busy, right? And then tell me whenever you are ready. Put it into my call stack or something. But with C++ compiled language, we do not have a parent process. We have the main thread which is running. So who is the counter there? As far as I remember, he told that if we create a variable and store it in some variable, then the first variable will not have that value because it should only have one owner. Shit. Okay, shit. So the variable name is acting as a key and the value is acting as the value. That is crazy. And if we create, so we must explicitly might copy or move the original value. And if we create a variable and we can create any number of pointers if they are not mutable, so they only point to that variable, nothing else. But if we have a mutable pointer, then we can change the value of the original value. Shit, so mutable pointer means a pointer to a value which is mutable, not that the pointer can point to something else later. The variable don't need to be mutable, but the original variable needs to be mutable. That is all crazy, and we cannot have any more pointers. Shit. I have also not learned. Let's say is that I try printing this every time I use a new language. Shit. Okay. Bro is learning a lot of languages, I suppose. Learn Lua. That is pretty nice. If we make a mutable pointer to a variable, then that makes the pointer variable mutable pointer variable, the pointer itself mutable. Anything I suppose is mutable by default in Rust. It is a very primitive and basic programming test I do. Bro has his own thing for learning languages. Okay, I don't know. This ChatGPT just begins with praising the questioner. Yes, that is the thing. In JavaScript, we do have Node.js, but what does a event loop look like in other language, like which is not running in an environment? The only environment on which it is running would be, wait, is C++ running in an environment? I guess in the operating system environment. The core idea. An event loop is indeed a mechanism designed to avoid wasting time waiting on slow blocking operations like IO. The essential goal: do useful work while waiting for other things to finish. Yes, this is what happens in JavaScript also. Reading from the disk is slow, so we do a function call, or like we use a async function to read stuff from the file from the disk, which is slow, and then we call a callback function whenever we want to, whenever that file has done reading. Okay, and that is the main function, a mechanism designed to avoid wasting time waiting. Instead of blocking a thread when something like socket or file descriptor isn't ready, the event loop asks the operating system, tell me when this socket becomes when tell me when, or like tell me right now after 5 seconds this socket would be ready, or I suppose which socket is ready or not is what is asked using poll. How it actually works step by step. You have a set of file descriptors, sockets, files, pipes, etc. Each file descriptor prints something you can read from or write to. It represents, okay, you give that list to a multiplexing system call, like select, old, and time complexity is O of n, poll, slightly better, Linux, epoll. Okay, so these are the functions which are multiplexing system calls. Okay, the operating system blocks your process or event loop thread until one or more file descriptors are ready. Example, a socket has incoming data or the send buffer is free. Once ready, the event loop returns control to your code with the list of file descriptors. So our main process is blocked till there is a file descriptor that is ready to be read from or something like that. Lol. I know, Lua. Bro, I use Neovim to shit. Do you use Arch, by the way? I see you got confused. It's kind of, it always plays first, then it does a lot of issue. Yes, it does. The pointer may or may not be mutable. Okay, the rest thing, the about the rest thing that I would be able to handle in a few days because the next chapter in the Rust book, uh, is about mutability. So I would be much more able to understand that in a few days. But if the pointer is a mutable pointer, then if the pointer is a mutable pointer, then the original value it points to must be mutable. The original variable must be mutable. Okay, it works as Babu working in government. Lol. It praises a lot. It has to be mutable, otherwise you cannot create mutable pointers. Okay, okay, okay. I do get this, but I don't get why this should be. Hello. See, you are grinding a lot. Keep it going. See underscore DM once free. Okay, after the stream, yes. And yep, thank you. And back to this thing. The more important thing here is event loop. Event loop. Yeah. And it is very fun to debunk these subtle misunderstandings here. And I suppose my theory is that these functions are handled by the kernel. I mean, yes, these are handled by the kernel. These are like syscalls, I suppose, to the kernel. And they're saying we give the OS a list of sockets that we want to write to or read from. And then the OS blocks our process or event thread loop until there is some file descriptor which is ready. And whenever there is a file descriptor ready, our process will handle it. Okay, that is nice. So as soon as we could do something, we are doing something. Socket has an incoming data request or something. Once ready, the event loop returns control to your code with the list of ready file descriptors you handle. Then you then handle only those ready file descriptors performing reads or write that you know won't block. Makes sense. Then you go back to step 2, finding the next ones which are ready and handle them. So whenever there is something you could do, you are doing. So that is nice. That is the loop part. Okay, that is nice. That is nice. Each iteration is a tick. Okay, I misread it as something else. Of the loop. The loop wakes up. We poll on all the file descriptors. We get the ready ones. We process the ready ones, and we loop again. We give in all the new all file descriptors. We get the ready ones, process the ready ones, and loop loop loop. Why it's better? Single threaded, more efficient, no blocking, less memory use. Okay, and scalable. Okay, so okay, that is nice. That is nice. In an interpreted language like JS, we have node, which is uh, which is returning or not, yeah, which is acting the part of, which is acting the part of this thing, pole thing, part of the which acting as the OS and returning, and is the one that is called when a pole like function is called, and in a binary, not binary language, in a compiled language which doesn't run in an environment like C++, the OS kernel does the part of returning the list of ready sockets. Is that the thing? And if that is the thing, then a lot of things are exactly. You have nailed it. Yes, genius, genius, as ChatGPT wants me to believe. The two worlds. There is no runtime environment maintaining in compiled language, maintaining your IO for you. You talk directly to the operating system via syscalls. These syscalls enter kernel mode where the OS keeps track of which file descriptors are ready. When one of them becomes ready, readable, the kernel wakes up your process or the thread calling poll. Directly calls the kernel. There is no middle layer like Node.js. This makes a lot of sense in interpreted languages like Node.js. JavaScript by itself cannot make syscalls. It runs in a sandbox V8 engine. Node.js acts as the runtime environment sitting between JavaScript and the OS. Okay, and when your JS calls something asynchronous like read or network request, Node delegates that operation to a C library inside Node. libuv uses the same OS level syscalls. Libuv is the C library inside Node. When these syscalls return ready descriptors, libuv puts callbacks into Node's event loop queue. So, oh shit. So in JavaScript, we have three different layers. Our JavaScript, then the engine, Node.js running V8, and then the C++ library, which are doing the syscall. The JS engine V8 then executes these callbacks when it is ready. So even Node.js is not making the syscall. Node.js is calling C functions which are making the syscall. So in a way, JavaScript is written in C. That is crazy. Golang. So you can learn it from within a few hours. Yep. If not minutes. Yep. Rust borrows this mutability concept from functional programming, where a variable by default is immutable. Shit, I saw this thing in the Rust for the first time, that by default a variable is immutable. That is, you cannot change the value once created. The values are copied unless explicitly mentioned as mutable or mute for short. That is the only concept. Yep, that much I do get. This is my I love Golang created threads. I super light and like unlike C and C++, so you can efficiently create hundreds of them, and it is asynchronous by default. So Golang does not actually have threads, not OS level threads, but threads on the language level, and therefore it is faster and we can create multiple threads, I suppose. This thing makes sense now. Loops, event loop makes a bit more sense now. So that is nice. Within an event loop, an application task can span multiple loop iterations. Makes sense. Okay, this makes so much sense now. This line makes so much sense now. Because let's say there is a client who needs to be handled, but it is just not getting ready. It is like not ready for 10 loop iterations. So after 10 loop iterations, when it is actually ready, we need to have the data which we need to respond to that client when we do respond to it. So the state must be explicitly stored somewhere. Makes sense. Here is our pre-connection state. Con file descriptor, initially nothing. Applications intention for the event loop. Do we want to read? Do we want to write? Do we want to close? Nope, nope, nope. Buffered input and output. Shit, that is crazy. We are storing our vector here, incoming and outgoing data to be parsed by the application and responses generated by the application. Shit. Okay. Connection want read and connection want write represents the file FD list for the readiness API. And want close tells the event loop to destroy the connection. And connection incoming, this thing buffers data from the socket for the protocol parser to work on, and outgoing. So whenever we can read, we read and put it here. And whenever we can write, we first process this thing that we have here, and then we write. And we write to this thing. And whenever we can actually write to the protocol, to the file descriptor, then we write this thing, and then we see do we want to close or not. If not, then we will see if we can read or write. A buffers generated a response that are written to the socket later. The need for input buffers. Yes, why do we need input buffers? Outgoing buffers make sense because we cannot immediately write. Makes sense. But why do we need incoming buffers? Since reads are now non-blocking, we cannot just wait for n bytes while parsing the protocol. The read full, okay, so in the read buffer, incoming buffer, we will get how much we can get or whatever amount we can get. Virtual threads work in Java. Virtual threads. I think you should learn about asynchronous programming first, then it will be more clear. Asynchronous. Yes, I think I should read more, but I started the stream and we'll just do this. And this is making sense. This is making sense. And when we write more code, it will should make more sense. Connection incoming buffers data from socket. Okay. Why do we need input buffers? Because we cannot read everything right now. So whatever amount we can read, we read and put it here. And whenever we have everything that should be read, then yeah, when we have the whole response or like the whole request, only then do we like parse and generate the output and put it here. Outgoing buffer function is now okay. We cannot just wait for n bytes while parsing the protocol. The read full function is now irrelevant. We will do this instead because this makes sense. Read full is now irrelevant because read full keeps like iterating till we do get the whole n bytes or whatever amount of bytes we have to read because we do not want to block our thread. Makes sense. Shit. This makes too much sense. Yeah, this makes too much sense. Loop iteration and everything. At each loop iteration, if the socket is ready to read, do a non-blocking read. Add, these are the steps. Add new data, add new data in the incoming buffer. Try to parse the accumulated buffer. If there is not enough data to nothing in that iteration, process the parsed message. If we did parse, then remove message from incoming connection. If we were able to parse, then we can remove thing from here. Why output buffer? Because we cannot write right now, so we need some place to store the output. Since writes are now non-blocking, we cannot write to sockets at will. Data is written if and only if the socket is ready to write. A large response may take multiple loop iterations to complete, so the response data must be stored in a buffer. This makes a lot of sense now. This makes a lot of sense. The event loop code. This just makes a lot of sense now, actually. Map from file descriptor to connection state. And this is our thing. Okay. Let's write something here. Event loop .cpp, and yeah, let's create our struct. It will be called connection, and it is going to have a few things, including our vector. Okay, first thing is an integer file descriptor, which is initially -1, or like by default -1, and then we will have boolean value want read equal false initially, boolean want write also false initially, and boolean want close. Do we want to close this? Not false, false, and now buffers. Vector unsigned integer or u int 32. We don't have to write 32, and we will call it in incoming is a nice word. Yeah, incoming. Yeah, that is nice. State. We are not using std here. Std and another vector unsigned integer out going. Cool. This makes sense. This actually makes sense. Yeah. Same thing here. Unsigned 8. Shit, 8 makes sense. Yes, we have to use 8, 8, 8, 8. Because we each, the smallest thing that we are guaranteed to get is 8, is a single character, which is 8 bits, not an integer, which is like 32 bits. 8 bits is something that we are like supposed to get. The smallest token, you could call it. Okay, map from FD to connection state. Okay, poll returns a FD list. We need to map each FD to connection object, each file descriptor to connection object. Or wait, what? Shouldn't we make a connection object whenever we do get a new connection instead of asking for poll? A map of all client connections keyed by FD, and this is a pointer. Okay, on Unix, an FD is allocated as the smallest available non-negative integer max. Shit, max function. Smallest available non-negative integer. So the mapping from FD to connection can be a flat array indexed by FD. Okay, and the array will be densely packed. Nothing can be more efficient. Sometimes simple arrays can replace complex data structures like hash tables. Holes returns a list of file descriptors. We need to map each file descriptor to connection object. But okay, this makes sense. We can do this on Unix. Okay, but what if we have like a lot of connections? Wait, that would also work. That would also work because whenever we get a new connection, whenever we are getting like new connections, we are also getting rid of older connections, and the new connections will take on the file descriptors which were held before by older connections, and they would be freed. Smaller integers would be freed, and on their index we could store the new file descriptors. That makes sense. Makes sense. So the mapping from FD to connection can be a flat array indexed by file descriptor, and the array will be densely packed. Nothing can be more efficient. Sometimes simple arrays can replace complex data structures like hash tables because of the fact that file descriptor is the smallest non-negative integer that is free. We don't have to use hash maps. We can just use a vector where the file descriptor is the index. That is cool. The readiness API hold. The readiness API takes a list of file descriptors that the program wants to do IO on, and also the thing beach in this is a guide to network programming. In this there is a single paragraph I want to show you, which is like amazing. And okay, I guess this is the one. Yes. Yes, you okay. 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 Yes, literally. Okay is the thing that is written. Okay, you may have heard Unix hacker state. Geez, everything in Unix is a file, right? What does that mean? And what is the extent of this statement? Like, is literally everything is a file? Let's see. What that person may have been talking about is the fact that when Unix programs do any sort of I/O input output, they do it by reading or writing to a file descriptor. A file descriptor is simply an integer associated with an open file. This singular sentence, a file descriptor is simply an integer associated with an open file, is very concise and very to the point and makes so much sense. A file descriptor is simply an integer. It is nothing more. It is simply every word that is used in this statement is like deserves a place in this statement. No word is extra and no word is missing. This statement is a perfect statement. A file descriptor is simply, this word simply is very important here. A file descriptor is simply an integer associated with an open file. Open is also a very important word here, open file. But, and here is the catch, that file can be a network connection, a FIFO, a pipe, a terminal, a read on the disk file, or just about anything else. Everything in Unix is a file. So we have a file descriptor API, you would say, which we use to write and read from a file. And since we have a API or method of reading and writing from a file, and we know that everything is a file, we can read and write to anything we want using the same method. And that makes sense. That is like amazing. Everything in Unix is a file. So when you want to communicate with another program over the internet, you are going to do it through a file descriptor. You would better believe it. This is just amazing. Yo, hello, beluga. And now the poll, poll. Yes. The Readiness API takes a list of file descriptors that the program wants to do I/O on, then returns a list of file descriptors ready for I/O. There are two types of readiness, read and write. This is the pseudocode. Given the list, two lists, and get back two lists. We will use poll. It uses the same file descriptor list for both input and output. Okay, wait, poll is a function which runs at the kernel level and returns a list. And they are saying that poll uses the same file descriptor list for both input and output. So poll for every given file descriptor will tell us which one is ready for reading and which one is ready for writing. That is cool. Okay, so what do we do? This is the, we don't have to read that. We can just look here. Poll, not pool. Synchronous IO multiplexing. Wait, shit, synchronous. This is synchronous. This is not async. Shit, that makes sense. Okay, okay, now this is expanding even more. Poll, when we call poll, we are giving it a list of file descriptors on which we want to do some reading and writing. And while poll is running, and also while there is no file descriptor which is ready for reading or writing, our main thread is blocked. That is what Mr. ChatGPT told us. That while that is happening, while things are happening, OS blocks your process. So this is asynchronous. But we could even have a way in which our main process calls this poll equivalent function and just moves past, just like doesn't look back and keeps moving forward and keeps executing the next lines while this poll like function is still checking which file descriptor is ready for reading and writing. And that is amazing. That is pretty cool. And that I would suppose means asynchronous. And here this is not async because our main thread stops. That is cool. That is cool. And what we are doing here, we are not making our main thread stop. We not stop. What we are doing is we are reducing the time for which our main thread needs to wait or stop. So that is okay. That is synchronous IO multiplexing. And this is the thing. This is literally the thing. Uh, the interface we give in an array of this structure, whole FD, set NU, set RNU, let's go. And we pass in NFDS. I think this is the number of file descriptors that we have and a timeout. Makes sense, makes sense. Pool examines a set of file descriptors to see if some of them are ready for IO or if certain events have occurred on them. The file descriptors argument is a pointer to the argument that we have to send. Yep, FDS argument is a pointer to an array of file descriptor structures as defined in pool.h, and this is the structure of which we are sending an array. An FDS argument specifies the size of the file descriptor array, and yeah, and timeout is just look for this much time. And this thing has, first of all, the first field is a file descriptor, integer, then two short values. This is 8, this is 32 bits, which is 4 bytes. This is 2 bytes, 16 bits, and this is also 16 bits. So the total structure is taking up 64 bits. I think that was irrelevant. Sort and events. and return events. I think the way that they are talking about events is flag based and binary. Hello, can you share your whim or talk about it a little? Yes, I suppose. Look at this. GitHub and nvim rc. Here is the whole thing, the whole config. There you go. And yep, you can explore this whole thing. We have the main init file, which has the main, and this is just requiring other things and prints welcome in German due to some ancient reasons. And then we have the Lua file. And yeah, there's just a lot of these, lot of things, and it would be hard to go into right now. But I did a stream about my new vim config, and do not watch it. It was very bad. Do not watch it. It was very bad. What you can do is watch a guy who is much better than me. Viro. This thing. You can watch this. Watch this playlist, and this is amazing. Good. Are you graduated or from where? No, I am in my third year, fifth semester. Not yet graduated. I'm still in the like matrix state. Cannot leave college right now. And yep. So this is very cool. This is cool, literally very cool. And yes, how are we telling which events are we listening for? Which events want do we want to listen to? And my hypothesis is, since this is a short, right? We have events. This is a short, which means this takes up 16 bits. And yep, we have 16 bits. Yeah, so these are 16, just believe me. And we will have bunch of these as zeros and some as ones, and yeah, the whole thing. And each bit, I would say, represents something. Let's say the bit at index, let's say this is the 0th bit, first bit, second bit. Let's say the bit at index 0 represents read. And if in this file descriptor that we are sending with this fd number, we want to read from it, then we will turn this bit on. And let's say this third bit represents write. And if we want to write to this thing, let's say we don't want to write to this thing, we are not checking this for writing, we are only checking this if we can read from this, then we will only put turn on the bit which represents read, and we will turn off every other bit. And the other thing that we get are events. What we will do with our events, or our event is just the same thing, 16 bits number, where each bit again represents some operation that we might be looking for. And if the socket is ready for that operation, let's say we turned this bit on because we wanted to write to this socket, and if the socket is ready for writing, then this thing would be on. And if the socket is not ready for writing, this would be off. And that is cool. And that makes sense. But I'm not sure if that is the exact thing that is happening. I just suppose it is the thing that is happening. Let's see. Yep, yep, yep. This all makes sense. This is the same thing here that we have here, right? And then, yep, NFDS, the number of file descriptors. Argument is the size of the file descriptor array. Timeout argument is set to -1, which means no timeout. Okay. And FD events is a short number. unsigned. Sure, okay, this can be negative. Cool. Is a combination of poll in, poll out, or poll error. Shit. Poll in means we want to write, poll out means we want to, yeah, poll in means read, poll out means write, like write, read. Okay, okay. And poll error indicates a socket error that we always want to be notified about. So we will have poll error always on, poll in and poll out conditionally on. And pool FDR events is returned by pool. It uses the same set flags to indicate whether the file descriptor in the can read and can write list can read and can write. Okay. Step 1. Construct FD for poll. File descriptor list for poll. How are we going to create that? But to do that, we first have to make connections and get file descriptors, right? Should a map of all client connections keyed by FD. Mhm. The event loop. Here is the event loop. And what do we have? Structure, poll, FD, prepare argument list, poll args dot clear. What poll args is this thing? Clear this thing. Okay. And what do we do? Put the listening sockets in the first position. Okay. Poll FD, FD. This is structure. PFD, not PDF. FD colon 0. Okay, FD, but which FD? And then polargs dot pushback. The rest of the connection, the rest are connection sockets. So first we clear this thing. Then we are adding one random socket into our poll arguments. This thing, the list that we will send to our event or to our poll function. Okay, the rest are connectionless connection sockets. For every connection in this thing, if not connection, then continue. That is, if it is empty, then continue. If the thing is 0, then continue. Yes, and create a new PFD where the first thing is the file descriptor, then turn on error, and 0 means 0. 0 is the timeout. And what are we doing? If we want to read to this thing, we are putting in read, and if we don't want to read, if you want to write, then we are also putting in write, and we put it into this thing. Okay, shit. Okay, makes sense. But do we have to do this every single time? That, yes, shit. Do we have to do this every single time? Here we already have a list of connections with their states, whether we want to write or read. And then here in this whole thing, wait, this would always be true. This is the event loop. Okay, this makes sense. Makes sense. We are doing this for each iteration of the event loop, which seems very slow. Like actually seems very slow because we are going through each socket. But this is also true, I would say. For each iteration of the event loop, we are touching every file descriptor. Okay. Okay. then call the poll function, prepare arguments. Then who filled this thing? Like, how did we got this thing filled? Then we are calling the poll function. Okay, and then what are we doing after calling the poll function? Accept new connections. Yes. Prepare arguments. Put the listening sockets in the first position. Wait for readiness. Okay. Wait for readiness, or like wait for something to be ready. And what are we exactly doing here? Yes, after creating our array, our vector, we are sending it to the poll function. And if uh, nothing is ready, then we continue and like go to the next iteration of the loop, right? And yes, error was no error. Then we go and do another iteration of the loop, then accept new connections. Okay, all of this is getting a bit abstract. Hello, we are trying to understand event loop and not just understand. We are trying to actually write event loop. So that is crazy. And this is a bit, yeah, this is getting a bit more complicated. I won't say complicated, just the steps are a bit, not too much specifically, but too many, right? And here I'm not very clear how we got this vector which is the list of all the connections. Wait, shit. I think I get it. I think I get it. Initially, this might be empty, might not be empty. We don't know. Let's write this. Let's write this. Okay, what are you going to write? Yes. Yeah. Int main. Okay. And now let's create a file descriptor on which we are going to listen for our server. Sys slash socket.h. Now, what do we have to pass? We will say if inet for IPv6, IPv4, my bad, and soft stream for reliable connection and 0 for IP version. And now we want to add some options to this thing. Static int on equals 1. Yeah, cool. Let's say we also have off equals 0. And now set sock option on fd, this file descriptor. Set the option at the socket layer, and the option is so reuse adder, that is reuse, let this socket reuse the same address again and again for accepting new requests. And yes, what should be the value of this thing? The value should be this on. We give a pointer to the value and also the size of the value, size of on. Cool. Now we want to bind this socket to a address on which our server is going to listen on, and that is also easy. We just create a struct sock, yeah, sock adder in, and yep, adder initially empty. We have this structure, but this structure is not here. This structure is like in some other thing, other library, and that library is this thing, net inet dot inet dot slash n dot h. Yep. And now we have to give this address some address sn family. The family is going to be IPv4. If inet means IPv4, and addr sn port. What is the port on which we want to listen? The port is host to network small 1234, and we have to call this function htons, which means which is a like short form for host to network small, which means the host, the computer, which is right here, the one I'm writing this code on, has some way of representing numbers, and the network on which this data is going to go forward, that might have some other way of representing numbers. So we have to call this function to convert the host's way of representing numbers to the network's way of representing numbers. And now we have specified the family, which is IPv4, the port. Now we have to give in the address, the IP address. SN adder, S adder, and this also we have to change host to network long, because this is a big number with a zero. Zero just means localhost, or like, yeah, kind of localhost. And then now we are going to bind this socket to this thing, to this address. Give the address of adder and size of adder, but this is going to give us error. Yep. No matching function called error, because we have to typecast this adder pointer to const struct sock adder pointer. Yeah, we just have to do that. That is how things work. And if bind was unsuccessful, we will get n smaller than 0. And if bind was successful, we will get n as 0. So if n is anything other than 0, then there was an error. And we will say the error cannot bind. After this, when our socket is binded, we want to listen on our socket. Listen on this socket for like 20 connections, right? At the time, we won't be creating more than 20 connections. That is all 20 means here. And if this thing returns the error in the same way that binds does, in case of success, n becomes 0, and in case of error, n is -1. So if n, which means error, if error, then cannot listen, like deaf or something. But if no error, then while true, we will start to accept connections. And to accept a client connection, we need a address structure like this. This address structure was used to put in the details about the host which is going to listen, and we need another address structure to store the details about the client to which we are going to be connected. So sock adder in adder, or like we can call this C adder, and it is also empty. We don't have to fill this. It will be the kernel, the operating system, which is making the connection, which will fill this. And also adder len, sock adder len. So now we have to pass in, yeah, we have to say the client file descriptor is, we will call the accept function sock len. Yeah. Sock len t equals size of C adder len. Len is the variable which has the size of this C adder struct. And now we will get the client file descriptor by calling the accept call. And we want to accept a connection on this FD file descriptor and put the details about the client struct sock adder pointer address of C adder, and some due to some reason we have to pass in not the length but the address of the length. Mm, which is crazy. I don't know why we have to do that. And yep, this is a new connection. This is literally a new connection. So what do we do now? That is crazy. What do we do now? Where did you learn this kind of C++? Because I only know basic DSA from the source, Mr. Björn Strauss. This guy, he's my teacher, and he has a book, the C++ programming language by Björn Strausstrup, and he is also the creator of C++, which is like a bonus fact, I would say. And yeah, you can read this book, and I would say this is very, very comprehensive and very difficult to read. But if you do actually read this, then PDF fail. If you do actually read this, this is one of the best things you can do. And yes, this is heavy, almost 1400 pages. I would say you can read this introductory material, which is amazing. Maybe not the last concurrency and utilities part, but in these 4 chapters. Note, okay, maybe not even notes to the reader, because this has history about C++. I haven't read this, and I don't, mm, yeah, I don't think I need it right now. So, bro, you got some MNC level stuff going on? Where did you learn this knowledge? No, no, I'm just like, you can read this. It is right here. You don't need anything special. Everything is written right here, right here. Like literally, you can search this URL right now and you can read this. Shit, I opened Blender by mistake. You can literally, like, you don't need anything special. You can just open this and start reading. And if things don't make sense, then read again, something like that. Shit, Blender is open. Yeah, you can like be as good as you want right now. You don't need anything special. And now we have to create our own socket. Shit. Wait, we have created our own server socket. What we have to do now is to find a way so that we can integrate this with what we are reading here. Poll, event loop. And shit, we would need some help with this. Yes, they have this section about accepting new connections. Uh-huh. Yep. Here, how are they doing this? Where is their accept call? Where is the accept call? Handling listening on the socket, checking for the readiness. Accept is treated as read. Where, wait, either I am blind or I cannot see, and both of them are the same thing. Handle accept, handle accept. Okay, this is our, this is FDR main file descriptor, our file descriptor for the server. If that is the case, then why are we putting this into the poll stack? Does not make sense. This does not make sense. Why are we putting this there? And we have a separate function, handle accept. Invoke application callbacks. Oh, this is crazy. This is crazy. And this is just part 1 of the thing. Yeah, you can ask. Yeah, and that is totally cool. Handle the listening socket. Uh-huh. Wait, where are we? Handling. Handle the listening socket. Listening socket. F poll args 0 dot r events if this thing is non-zero. If we can do something with this, or if we want to do something with this, then for each connection handle accept new requests. If this thing equals this thing. Okay. eh, Shit. Okay. This makes sense. We are getting a new connection and handle accept. Handle accept is a function which accepts a new file descriptor if there is some new file descriptor or new connection, new client connection, and this function will return a connection type. What is a connection type? A connection type is this thing. Connection structure. This thing will be returned. That makes sense. That makes sense. So we are not calling this accept function barely. We have a wrapper around this which converts this integer which is returned by this accept function and converts that integer into this behemoth data structure or struct. And we have this, we get a pointer to that thing. Okay, and we put it onto the map. Okay, shit, this is so cool. This is cool. This is cool. Resize. Okay, this is so cool. Okay, and then we put this new connection onto our file descriptor. Okay, let's write the handle accept function, which will return a connection pointer handle accept, and this takes in of the file descriptor for the server. And what does this do? This will create a struct sock adder in, like this will do the same exact thing that we did below. C adder initially empty. Yep. And then we have sock length type equals like length of this C adder thing size of C adder. And now we have to call this accept function. Client file descriptor equals accept connection on this server file descriptor and store the details are const struct sock adder pointer address of C adder and and yes, this is crazy. We do not have to pass in the length. What we have to pass in is the address of the length. That is how internet works. And now we have to create a new struct. This is struct on the heap. And we can use new function for that actually. Do we actually want to use pointers? Okay, let's use pointers. Con pointer new connection equals new. I think this is okay. Yeah, this is okay. And in this new connection, we say that the file descriptor is equal to the client file descriptor, and everything by default is false. What we want to do is want read, or in this new connection, want read equals true. We want to read from this CONN. Yeah, on this new connection, we want to read, and that is kind of it. We can just return this new connection. Okay, that is cool. Mhm. That is cool. So we don't even have to do this. Wait, shit, we don't even have to do this. Now we can, inside this loop, we can become pro programmers and call this loop not just a simple while loop. We can call this loop event loop and think or make ourselves believe that we know more than we do know. Okay. Yo, what's up? Happy Sunday. Shit. Yes, it is also Sunday in America. Hmm. And how is everything going? Is everything amazing? It should be. Well, if it is not amazing, then yeah, it depends on the perspective, I would say. Yep. I'm from UP. Life is good. Life is good. Life is just how you make it to be. That is amazing. Yep. Shit is yeah, the camera is working. That is nice. Which part? Yo, West, UP West, near Delhi. Shit, bro wants me to DOS myself. Wait, seven is a nice number. Seven is like, yes, the default human number. Okay, so we have our event loop. We have our event loop. We have a function which can handle new connections. Now we have to write the event loop. And in the event loop, there were these steps. Let's go from the first step. Construct FT list pole. Yep, we need two vectors. A vector for pointer of all the connections of the connection data type, structure, and pole FT struct. Okay, vector or standard vector of connection pointer file or FDs. Yeah, let's call them FDs, and standard vector for struct, which is struct pole struct. It was called pole something, pole FT. And what will we call this? We can name pole args, because we are going to send this as an argument to the poles. And also we have to include pole.h, double L dot h. And in December, I'll be traveling to Finland finally. Should your father has something to do in Finland, I suppose? You're right. And 10 December. Yep, that is nice. Finland, Helsinki. Let's go. And yeah, that is nice. Finland. Finland is nice. Scandinavia. While true. What do we do? Yep. And we have to do amazing things now. We will say poll args dot clear. If we have some backlog somehow, we will clear the backlog. Makes sense. And now we want to put things into the poll argument, poll args. Uh, Yes, first clear the thing. And wait, I don't get why we are doing this. Shit. Put the listening sockets in the first position. Listening, why are we saying sockets? We only have one listening socket on our server. Yes. But anyways, we will put that server listening socket into the first position, and the rest are connection sockets. Yep. Then continue. Yep. If no connection, then mhm. Otherwise, make a socket, a, like PDF, PFD, whole file descriptor structure type, and see what events we want to do on that, and accordingly put it into the poll arguments. That makes sense. That makes like actually too much sense. Yep, business trip. Yo, let's go. Business in Finland, Helsinki. So currently you are studying computer science at what university? I don't go to college. I have taken admission, but I don't go. Kind of, kind of enjoying. And yes, AKTU, by the way. How is Socket going? Socket is going amazing, by the way. Event loop. We are writing our own event loop. And this pseudocode just makes too much sense. Like, I don't think a pseudocode is supposed to make this much sense ever. This is so clear. We have a list of every socket or file descriptor we want to read from, and a list of all the file descriptors we want to write to. We call a function and give both of these lists, and we get lists of all the file descriptors which are ready to be read from and which are ready to be written to. And we are only reading and writing from, reading to and writing from, reading from and writing to only the file descriptors which are ready. So essentially, we are not waiting for anything to get ready. We are only writing to the things and reading from the things which are ready. That is nice. That is like actually pretty nice. We are not creating any threads. We are not wasting our time. Whenever we could do something, we are doing something. Right. So this thing is clear, and struct whole FD structure. We will call this PFD whole F file descriptor equals, the first thing has to be the file descriptor, which is FD in our case. And what do we want to do with this? We don't want anything and we don't need anything. Yeah, that is nice. Right. We'll look at the code later. And then we do poll args. It is the LSP is working. Poll args dot push back PFD. Yep. And now we will loop through all the connection sockets. At the first index, we do have the listening socket, the socket on which the server is listening on. And now for every connection pointer connection con in the FDS vector, we are going to see if con, right? If there is a connection, or wait, if there is no connection and this particular connection socket, then continue. And if there is a connection, we will make a new data structure of whole file descriptor type and put it onto our whole arguments. And the whole thing that we are doing essentially, that is a lot. Remember, you said that in a few days you would be completing 200 questions on lead code, and now 300 plus 350 plus. That is cool. I've dreamed to solve the entire lead code one day. It will be cool. It will be cool. I guess that is possible. You can do that. There is a Chinese tennis player who is like very good, one of the top lead code persons. Yep, I am on a Mac. Unfortunately, I do not have Intel processor. I cannot run Linux. That is bad. Uh, Chinese or Taiwanese, I don't know. OG lead coder tennis player Minlin. Yeah, refers to, should, that is actually the name of the guy, I suppose. Seems like this guy Marlin. Uh, I guess he's in the top kind of, and a lot of views and this many submissions in the last year. He has solved 3,721 questions. That is cool. Peng Kao is rank 1. Chinese are so good in coding. Yeah, they are somehow really good. Jiang Li on Code Forces is from that. KQ, it is then. Wait, what is KQ? It's something like K-pop. And this guy is rank 1 and he is a tennis player. He is in his uniform. Olympic champion. Olympic champion. Bro is Olympic champion of men's singles in table tennis. Coding for fun. Bro is just like side quest. Wave of the hand thing. Side quest. Shit. That is cool. That is flex. So you should check out libuv as well from Node.js. Shit. We just read about libuv. It was here. Like, yeah, in compiled languages, we talk directly to the kernel. In JavaScript, we have libuv. Yes, shit. Call back. Or a 9000 plus, yep. Legendary player. Have you done Olympiad maths ever? Hmm, I've not done it. I have thought of it. Maybe no. Yeah, it helps in CP. I hear a lot as well. In Olympiads. Ah, that is nice. I mean, I like looking at the questions of Olympiads, like not specifically searching for the questions and then solving them myself. But there was a three blue and one brown video on one of the Olympiad questions, and I was able to understand what the solution was. So I thought that was pretty cool. And this thing, yeah, right here. Bro, bro has done Olympiad maths. That is cool. Olympiad maths. Maths is like really cool. Struct pole FD structure PFD equals, for this current connection, we will get its file descriptor, and everything can be zero. Everything else can be zero. Yeah, everything else can be zero. And now we have to see if we want to write or read from this thing, right? So yeah, so if connection want read, if we want to read from this connection, then pfd dot events or with poll in, poll in, yes, turn on the poll in flag. And if we want to write to this connection, then in this pfd we will say events, add this event of poll out. That is nice. And then we can just push it. Poll args not push back this pfd poll file descriptor. I think that is nice. That is pretty nice. Let's see the correct version. Okay, we clear the whole thing. Then yes, with zero poll in, we are saying we want to read from the main server. We don't, I don't know if we have to do this, and we always have the poll error in every other thing. We are always looking for error. Yeah, let's say, okay, we are always looking for error. And if we additionally want to read, we will be checking for read. We are putting in, turning on the read flag. And if we want to write, we are turning on the write flag. And just this method of putting things on, turning on a byte by taking in or, is pretty cool. Okay, this thing is just a number and the value is 4. 4, 4 is 001. The from the right, shit, this is the right. From the right, third byte, third bit, that is 4. And yeah, so that third bit from the right represents read in. Yeah, a reading, writing event. And this would be some other number. Yeah. So the first byte itself from the right represents read. And shit, event loop. Okay, we still have it here. And this thing also must be something, some value, integer value. 8. So the fourth byte from the right, the fourth bit from the right represents error. And we turn it on if we want to check for errors in our current socket. That is nice. And we will not turn this as poll in because I do not know why we would do that. So yeah. And what level you qualified, bro? Yo. Maths and coding is all I can do all day. Shit, bro is too much into this thing. Is US is US wait, what you asking me or this guy? Is US there as in National Olympiad held and from that only I got chance in Highland Park as well. Shit, you got admission into your high school because of the Olympiad. That is pretty cool. That is pretty cool. If that is what you mean. From that only I got chance in shit. That is cool. That's cool. Okay, so we have written this part of the event loop. Nice. Now we want to call the poll thing no is error integer return, not an error. But if we have just rv smaller than 0, then we call die, the die function. Okay, and now here we are calling the poll. Okay. And okay, yes, now we have to call the poll function. Int n or like return value poll function. And yes, in the poll function, we will pass in this thing that we just created, poll arcs, and how many connections are there in this poll arcs. That would be size of, or shit, we can just, since this is a vector, wait, shit, poll arcs dot data, because we have to send in the raw vector. Poll arcs dot size, and then the timeout -1 represents there is no timeout, just like go on forever. Now if ret smaller than 0, that is an error. I don't know what is no error thing, like what is this error number. If error no equals, okay, I just don't want to blindly copy paste. Yeah, Highland Park give preference to students who come from National Olympiad. Yes, I guess they should. They should. National Olympiads are crazy. Let's go ChatGPT. What is L? What is Elno NC? Yeah, what is Elno NC? Shit. Let's go. Man pages. Number of last error. Wait, that is actually crazy. Shit. Now I get why this first thing has to be Poland, because when we are sending this poll args to the poll function here, then it is also going to check the socket which the server is using for listening. And there is only one thing that you want to check on that listening socket, and that thing is there another incoming connection? So that if there is another incoming connection, that is the only time when we call the accept handle function. Because if there is no incoming connection, then we do not want to waste our time and wait for any new incoming connections. Okay, shit. Eureka. That actually makes a lot of sense. Number of last error. Number of last error. Number of last error. What is the number of last error? Okay. And here, error int r. So, error int r. No definition. The value is just 4. No definition. It just says 4. Yeah, it just says 4. Returns. Okay, so this is the last error, and e int r. So we can look it up here, and this thing is in the error no dot h. E int r, interrupted syscall. Okay, if we got some error because our syscall got interrupted, then there is no error with the like sockets that we are working with, but the error is with the kernel with something else, and we don't have to do anything with it. So yeah, that makes sense. If ret is smaller than 0 and the error is error int r, interruption error, then continue. Okay. If there is an error and the error was interruption error, then it is okay. Do not break our complex event loop. But if we just have an error with no interruption, then break it. I mean, they're calling the die function, whatever it is, the die function. Uh, Poll gave us an error. Right, right. That is cool. That is cool. We have called the poll function. Now, what do we want to do? We want to accept any new requests. So, if okay, we can actually like add a few comments. That would be nice. Creating the poll args args vector. And then comments are not really making a lot of sense here because everything makes sense. Everything here, I do not want to say calling the poll function because on the next line we are literally calling the poll function. So comments though are not really making a lot of sense here. And here, does this make sense? Writing by commenting here, creating the poll args vector, does it make sense? Because here we are literally doing the same thing which we were writing before. So I guess we can write this without the comments. And now, if there is an incoming connection, then we will accept it. So how do we check it? If poll args 0 dot r events equals poll in, then there is an incoming connection. And why does this code work? Because here the first argument to poll args, we specified it here. The first argument is going to be the main listening file descriptor, the main listening socket. So that makes a lot of sense. And for that file descriptor, we are checking for the return values. Can we read? Is there an incoming request? And if there is, then we will handle the incoming request. Handle or connection pointer connection equals handle except on this file descriptor, which is poll args 0 dot ft. And now we have to add this file descriptor onto our like whole thing of file descriptors. Yeah, and yeah, what is the file descriptor? File descriptor is connection ft if fds dot size is smaller than connection file descriptor, then we have to resize this thing. Then we have to resize. -1 is smaller than connection file descriptor, then we have to resize this fes dot, because there is just not enough space, because we want to use the file descriptor as the index in this vector, and if the size is not enough, then we have to resize the thing. Connection fd plus 1. This should have this many elements in total, because we want to index connection fd. Therefore, the size should be connection fd plus 1. And after this, we can just do connection fd, this thing, connection fd equals 10. Okay, we are handling a new incoming request. Yeah, now what we have to do, we have to actually do some stuff now. Accept new connection, done. No, 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 yeah, here. If our events, and this is also one thing we could do instead of explicitly checking for that, but yeah, this would also work, and what we have written would also work. This thing would also work, and this is actually more clear, a bit more clear. Get the first connection if it does exist. What would be the case in which this thing does not exist? Like, why would this if statement ever be false? I don't think this would ever be false. I guess reading some more would make that thing clear, but yeah, I don't think this if a statement would ever be false, because handle file except, wait, 0, okay, handle except, we are calling handle except directly on the file descriptor, makes sense. Why would this return something off, like non-existent? I guess handle file except would return something bad. Handle connection sockets, where is handle file except? Handle except, yes, this thing can return null in some cases. Okay, okay, that makes sense, that makes sense. Instead of, that makes sense. That makes sense. If there was a client which wanted to make some connection, but and when we initiated from our side, proceeded from our side to start making connection, the client messed up and we were unable to make a connection. In that case, we wouldn't want to add this file descriptor, yeah, this socket onto our list of sockets. And that makes sense. That makes sense. Now we have to actually handle the clients which are handleable at this point. Invoke application callbacks. Shit. Now we have a list of all the file descriptors which are ready at this current point in time in life, right? In our pseudocode, original pseudocode, what we have written till now, this whole thing, this like 87 lines of code, not 87, yeah, this many, this is 35 lines of code. They mean, they mean to represent this pseudocode. We had a list of all the sockets we wanted to read from, a list of all the sockets we wanted to write to, and we got a list of all the sockets which are ready to be written to and to be read from. Now we have to move on to this step. we have to handle these clients which are ready to be handled and invoke application callbacks. Okay. The rest of the file fd list is the rest of the fd list is for connection sockets. Call the application code if they are ready for IO. And by application code, I suppose they mean the code which is handling clients. Yep, we got the readiness. Yep. We did give -1, -1. Cool. Yes, we agree. And now handle connection sockets. I is smaller than this dot size and shit. Since I equal to 0, we are starting from 1 and not from 0 because at 0 we have the listening socket and that is not a connection socket. We do not want to handle that. We only want to handle the listening sockets, only the connection sockets. And the first socket at index 0 is not a connection socket, it is a listening socket on which the server is listening. So we don't do this. Yeah, we are starting from 1. That makes sense. Yep. And shit, this thing is triggering. This pre-increment is somehow just triggering. I don't know why people pre-increment. You could just do I plus plus, but some people do this pre-increment. That is crazy. Like, this is my OCD is triggering whenever I look at something like this. And now ready. R events, whole args I dot R events ready. What is the thing ready for? Makes sense. Makes sense. We get the connection state, handle read if we can handle read, handle write if we can handle write. This is application logic. This is application logic. Handle read and handle write are application level functions. Okay, that makes sense. And they take in a connection. Okay, that makes sense. That makes sense. We can do that. We can do that. What we will have is void, a returning void, handle, read, and this function takes in a connection pointer, con or something, and does something. We also have a handle, write function, connection, which we will like implement later when we are better. For now, we are going to go through everything. So for I equals 1, I is smaller than I is smaller than FDS, nope, not FDS, whole args dot size I plus plus, not plus plus I plus plus. And this thing is like doable. We can do something with this. And now what we want is connection pointer connect to this particular thing, and that is in our FDS vector, the index whole args I FD dot FD, and also int result would be whole args I dot R events, right? Result is an integer which we can use to see which operation can we perform on this connection socket. If we can write on this socket, we will write. If we can read from this socket, we will read. And where is the socket? This is the socket. This is the socket structure. Okay. So if result bitwise and poll in means read. And if we can read from this socket, then we will do handle read on this connection. and if result and poll out is right. If we can write, then we will write on this connection. That is kind of cool. Yeah, that is it. That is kind of it. Yeah. Yep, that is literally it. Get the ready state, result state, and application call logic. Okay. Terminate connections. Terminate connections. Okay, let's not look at the code. We can terminate connections right here, for which, for terminating the connections, let's go to for in I equals 0, I is smaller than fds dot size and I plus plus. And if whatever the, let's get connection pointer equals fds I, right? If connection want, if you want to close the current connection, then we can just do this fds I equals null. Yeah, the current connection is closed, but shit. Okay, what we also have to do is delete connection, because this connection is on the heap. So keep this in mind, right? Memory safe code, memory safe. Yeah, delete the current connection. Look at this. Yes, they are also doing the exact same thing. Yep. This is the previous thing. Now, if ready and close the socket from socket error or application logic, read and ready, and we, if we want to close the current connection or ready, and or there is a error with this current connection, then close this file descriptor. Yes, yes, shit. Okay, yes, we have to do call the close function. Makes sense. And we are putting this equal to none, and we are freeing the memory. Okay, that makes sense. Okay, now, so okay, if result or result and whole error, if there is a error with this current connection, or we have connection one close, then first of all we will close this, close connection ft, close this undeclared, because where is the close thing defined? It is defined in some unistd.h, I suppose, maybe. Yeah, and that is where it is defined. We have closed the connection. Now we want to do pfds whole args I dot fd equals null. We put this equals to null, and we have to delete the memory that it is taking, for which we can just call delete connection. Cool, cool, cool. That is working. That is working. That is all working. Shit, that is all working. And now we can just write the application side code. Event loop. This is our event loop. This is the whole thing. Event loop. Yeah, that is our whole thing. Let's put this onto GitHub. Git add current thing, git commit message. added event loop, and yep, added the event loop, and git push origin, push origin master. Yep, it is on GitHub now. That is cool. And let's repetition is very good when we are learning. So let's go through this whole thing once more, starting from here, right? The event loop code. This whole code that we have written is the event loop code, and then there is the application code, and then we are done. Application code is the last thing that we have to do. I don't know if we will be able to do it today. I guess we should be able to do it today. Yeah, and we'll read this, but before that, let me go to the washroom. I will be right back in a minute. Yep, I will be right back in a minute. Yep. Let's complete this whole thing. We have already written the code for event loop. Yeah. Let's go through the theory once more because yes, repetition is very good. Map from FD to connection state. And they have explicitly written, but let's write our own thing here. Steps in event loop. We have 5 steps. As any child would know that the first step in a event loop, like there is no mm, concrete step-by-step method. Everyone can have their own implementation of a event loop, their own design. What we have done is, first of all, before moving, let's say we have two data structures. Specifically, we have a vector we have two vectors. One vector has all the list of connections. One vector is a list of connections, and another vector is what we will pass on to the poll function, which we are calling at some point. Uh, this one right here, this other vector, which we are calling, which we are sending to this poll function, giving this as an argument. So this is, let's say, just this poll args vector. Yep, these are the two vectors. Now, the first step in our implementation of an event loop, this is not a standard. Everyone can make their own implementation of a event loop. This is just what we did. So in the first step, we have converted the connections, not converted, but filled the poll vector. That's right. Fill poll args with data from connections. That is the first step. Shit, medium is too small. Large is fine. That is the first step. Let's make this blue. Blue is good. Let's make these two green. Yeah. And this is white. And the second step after creating our polls argument, yeah, we have our polls argument filled. What did we did after that? We call, we call the poll function. Yeah, call the poll syscall or function, whatever you want to call it. Then handle a new connection, right? If there is a new connection, then handle it and put it into the connections vector, and then handle ready connections. Handle all the connections which are ready to be handled. And then, yes, and also one more thing in this, by calling application logic, right? Makes sense. And in the last step, terminate, uh, terminate connections, terminate connections which are not needed. Yeah, cool. Terminate the connections which are not needed at the point currently. That is nice. And that is our whole thing which we have done here. So let's read this thing again. Event loop code. Map from file descriptor vector to connection state. All, uh, uh, yeah, all those things. Step 1. Construct FD list for poll. That is the list which we are going to send to the poll function. We have to construct it from the list of all the connections that we have. The application code decides the type of readiness notifications. Yes, application code decides the type of readiness notification. That is what kind of readiness we want from a particular socket, right? That is decided by the application logic. Yes, either we want to read or write or whatever we want to do, that is decided by the application logic. It communicates with the event loop via want read or want write flags in connection. Connection is the data structure. Here, yep, this one. Yeah, this is making so much sense now. This is like literally making so much sense, and a lot of things have been demystified here. So, in the first step, we do this want read, want write. If the application code wants to read from some socket, it turns this value in the structure on, and if the application code wants to write, or yeah, whatever the application code wants to do with some socket, it turns these flags on and off accordingly. Yep. And in this whole code, we are just converting the thing which our event loop got from the application code into the arguments, into the list that we are going to send into the poll function. Makes sense. Okay. And call the poll function. Then we literally call the poll function to check which one of these file descriptors is ready for whatever thing we want them to be ready for. Either we want to write or read. Poll is the only blocking syscall in this entire program. Yes. Poll is the only thing that is blocking. Yes, everything else is non-blocking. That makes sense. Yes. Because if there is no file descriptor that is ready to be done and that is ready, then poll will block the main thread. Yeah, poll has that property. So yeah, okay. So poll is the only thing that is blocking. Normally it returns, and here lies a subtle thing. Since pole is blocking, this is called synchronous programming. Right? Yeah, since pole is blocking, this is called synchronous programming. If pole was non-blocking, in that case, this would be called asynchronous programming. And that is the only difference between the two things. That is too good. However, it may occasionally return with error integer, which means, okay, either it blocks, normally it returns when at least one of the file descriptors is ready. However, sometimes it might return some error, which is this error. This is the only error that this thing would return with, and this is error INTR. INTR is interruption error. That is, the poll was doing polling its own thing, but somewhere down the line, some interruption happened. The poll function got stopped in the middle, and the poll function returned with this error. That is okay. Yeah, nice. If a process receives a Unix signal during a blocking syscall, the syscall is immediately returned with, okay, if a process receives a Unix signal during a blocking syscall, the syscall is immediately returned with EINTR to give the process a chance to handle the signal. EINTR is not expected for non-blocking syscalls. Shit, if there is some process which is blocking, right, it is doing something and keeps on doing something, and the whole main thread is stopped, has stopped, and then if there is a Unix signal, what is a Unix signal? Unix signal is this thing, Control C, literally Unix, that is Unix signal. Shit, I was just looking at this today, and that is pretty cool. Shit. I didn't know that we were going to read about Unix signals, but coincidence. Okay, now we can like get our hands dirty and actually test something. Let's say we have a blocking syscall, which is a while loop, which keeps on running, right? And signal, I'm saying that the signal is control C. That is the signal. So we can actually check if the user prints control C. Let's see. We will keep running a loop, and if the user presses control C, then we will print control C pressed and then exit. So if error number at any time equals error interrupt, that means, wait, error INTR interrupt, that just means there was an interruption, some like control C interruption. In that case, we will do printf on check standard cout view test press control C. I know I can see you. Okay, if that happens, also a new line. Yeah, if the user presses control C, then exit and exit with 0. This should work. Wait, what is this? Custom function. Let's see if this is in good. Hello.cpp out run. Okay, it is running, and if we press Control C, shit, nothing happens. Okay, nothing happens. Maybe Control S. or control D. Shit. Okay. Okay. So my understanding is a bit messed up. This is not exactly what is happening. Okay. Uh, when error number equals error interrupt, that means that our wait, what was there? Who is making this thing? It may occasionally return with error even if nothing is ready. If a process receives a Unix syscall, a blocking syscall, the syscall immediately returned with intent to give the process a chance. Okay, we are not actually calling any syscall. We have a main loop which just keeps on running. So do we have to call a syscall for the value of error no to change? Let's see if this code is correct. Control C, no. When error number equals EINTR, that means our function was interrupted with a Unix signal, and that signal usually is control C. All right, that function, that interruption usually is control C. Okay, okay, and if I simply have a while loop, nope, if I simply have a while loop that is running infinitely, then that is running infinitely, then thus doing. Yep, the main question is just this: how do we capture control C? How do we capture control C in CPP? Right, that would be the nice question. The terminal driver part of the OS, not your program, recognizes that control C ASCII character this thing has been pressed. It sends a signal called SIGINT, signal interruption, to foreground process group. Usually your running program. By default, the thing terminates the process. So we have to check if this thing is on. Handle SIGINT, okay, while some true, simulate work, register, handle, okay, for SIGINT, do this. Okay, okay, makes sense. So in C++ or maybe like in newer functions, what we have to do is this. Yeah, not error number, but SIGINT, signal interruption. Whenever we get this signal, run this function, which is taking in an integer, the signal number, and yeah, cool. Okay. Hello.cpp handle signal and s doesn't matter, or we won't write a new line. We just copy this one. This makes sense because if we just have this thing running and if we press Control C, then the program exits. Like, yeah, when the program exits and nothing is actually happening. Signal, signal, interruption for the interruption signal, call, handle, signal. Should be working now. Function is running, Control C. You just pressed Control C. That is nice. I know. I can see you. That is nice. We can capture Control C. That is like actually pretty cool. And now getting back to this thing. Okay. This thing is returned by syscalls, but since we were not doing any syscalls, this thing is not getting changed. Error number is not changing. Yeah, makes sense. And then error interruption is not expected for non-blocking syscalls. For non-blocking syscalls, because they are non-blocking, they just go and do their call, do their thing. Error interruption is not an error. The syscall should be retired. Even if you do not use signals, you should still handle e error interruption because there may be unexpected source of signals. Okay, okay. Accept new connections. Then we are just accepting new connections in this part. Here we are seeing if there is an incoming request in our listening socket, and if there is, then we are adding it to our connections list. That is just it. Accept is treated as read. That makes a lot of sense and explains why we said that we want to read here poll in for the listening file descriptor, because poll in means read and we want to check for acceptance, and they are saying acceptance is treated as read, so that is why we do poll in there. In readiness notification, so it uses poll in. After poll returns, check the first file descriptor to see if we can accept. Handle accept creates the connection object for the new function. We will code this later because this comes in the application side code and is not a part of the event loop which we are trying to code here. Invoke application callbacks. Shit, yes. Now we are at the thing. What have we done till now? We created the argument which we had to send to the poll. Then we did call the poll function, and after calling the poll function, we handled some new connection, and now we want to check, like we want to handle these ready things within the sockets which are ready, the file descriptors which are ready for whatever task they are supposed to be ready for. The rest of the file descriptor list is for connection sockets. Yes, makes sense. Call the application code if they are ready for IO. Yes. If the socket is ready, then we call the connection call. Ready contains the state, right? Return events which were returned by the poll function earlier here. And here is the connection state for this current socket that we are at. And if ready to poll in, if we are ready to poll in this ith socket, then we handle read. Poll in means read. And if we are ready to poll out means write. If we are ready to write, then we handle write on this current connection. Makes sense. And terminate connections. We always poll for poll error on connection sockets, so we can destroy the connection on error. If on some particular connection we have some error, if on some particular connection we have some error, then we want to close the thing. Like if we have the want close flag on, then also we want to close the connection. And in closing, we first of all like literally close the connection. Then we null make the make its place in the file descriptor equal to null, and also delete the connection to free its memory. Makes sense, I suppose. And then you can add a callback handle error. Why would we handle error? I think we don't have to do that. And then now the application side code. We have done the yep. We have written the event loop code. Event loop, event loop. Yep, says event loop, which is 56 lines long. And now we have to write the application side code. That is crazy. Okay, let's go. Okay, application code with non-blocking IO. Non-blocking. That is when we call a syscall on whatever the thing is. It is non-blocking. Like it does not wait and shit. File descriptor. Yes, to change the nature of a file descriptor, we call this function fcntl. File descriptor control, cntl control, which we can read about from here. Fcntl file control, not file descriptor control. I'm at file control, and this comes in this header fcntl. And since everything on Linux is a file, we can use this to do anything whatever we want. Let's include this fcntl.h. Yep. And LSP info. LSP is running. Why is Vim LSP running? Clang is running. Clang D homebrew version. And there is also a log size is too much. Log. Shit, is that why the LSP is slow? Because the log size is too much. We can just delete the log file, which is right here. Users /dot local state new clear rm rf dot slash local slash state new slash lsb dot log. I think this is the thing. Shit, nope, this is not. Slash local slash cd dot log. Shit, we are in some crazy thing. Yeah, now we are okay. Dot local slash state slash nvim slash lsb dot log. Okay, now we should not be getting that error. Miss and lsb info. Yep, there is literally a green tick here now. Log size is 0. That is okay. And since we just saw that the LSP gave us some data, that look at this here, expected this thing. So there must be some logs in the LSP, and the log size should not be 0, but it is 0 still. 0 kilobytes because okay, I think it depends on also depends on the precision. If we literally go there and cat local state nvim lsp.log, no such file. Shh. Let's create a file. Shit, local state nvim lsp.log. Okay, we have the file. Emacs attach missed event looplets. Right. and do the event loop thing. And actually, what we can do is, like good programmers, take all of this thing, yep, and write these three are application side code functions. So we can move them into a new file and call that application side code or application code. Application code.cpp. Paste. Shit, don't paste this. Thread server request application code event loop. And yep, we have harpoon running, which is pretty cool. And we can switch between these two files very quickly. Look at this, that is very quick. We can switch between them however we want, very fast, very quick. And these are the three functions which you want to define there in the application code. Makes sense. What is the connection thing? Yes, makes so much sense. We have to take this away. Do we want to copy paste? Nope. We don't want to copy paste. That is bad idea, bad design. Structs.cpp. This is going to have in this file we will have this code. Std vector does not exist. Yeah, include vector now. Okay, and what we can do is in this file do include structs.c dot slash file not found, because we have to save this now. structs dot okay, makes sense. This is structs.cpp. Yeah, now that works. And yeah, back here we'll do the same thing, include structs.cpp, and also we have to include the application code. Redefinition of con. Shit. Shit. Okay. Shit. Because here we are including the literal C++ code instead of you just including the headers. That is why we are getting redefinition error. So instead of literally just copy pasting the code, we have to, I think we should create a separate directory for all the header files. Header, we'll call it header. And here we will have the header files. Okay. Yeah, event loop.h, even though we don't need, yeah, we don't need event loop header file. Application code.h. What do we put in here? Here we will say that first of all we have to include the header file in this header file for the structs, and then yeah, this whole thing, header paste. And now we have to create the structs header file, structs.h, which shit. How can we define a structure in a header file without how do we give a pseudocode for a structure? Shit, that makes sense. That's like, how do we declare a structure without defining it? How's the project going? Do you have to complete the second part as well? We will see. I guess we will see. But event loop is actually pretty cool. Which source who used when doing web development? You would recommend Harkirat source course is pretty nice. And I guess for web development, you can just hop on to next docs, Next.js. These docs are amazing. Like, even like they look very beautiful. Look at this. Look at this. Look at this. They have syntax highlighting and everything. You can see the code in TypeScript or in JavaScript. This is just beautiful. And shit, only this thing changed to JS. Yeah, nothing changed here. Only this thing changed. TSX and JS. Yeah, you can read this. No, there is eloquent JavaScript yeah, edition, whatever edition. This thing you can read about JavaScript here. This is also nice. Free Code Camp course. Free Code Camp is very nice. They are very good people. Yep. You can read this. This, I would say, my web development is not very good because I did web development when I was I would say, when I had a different mindset. So if I were, when I do start web development again, then I would be much better now than I ever was before, because the mindset is different. React, there is React docs right here. Learn React, you have this thing. And in here, you will create a tic-tac-toe game in React. Installation, React compiler, you can read about whatever you want here. And learn React, all of these things. That is nice, you can do this. Yep. Mindset, different mindset, yeah. Yep. And I would even say, if I were to give JEE exam again, then I would perform much better than I did back then, because of the mindset. The mindset is just different than it was before. And what are we trying to do here? Yes, how to declare a struct in C++ without defining it. How to define, my bad, shit, how to, not declare, just, yes, declare a struct in C++ in .h file, like, not .h, in a header file, I would say. So it will take quite a bit of time for this project. Not quite a bit of time, at most 2 weeks from now, at most, at most. If I include, the second half of the project, this thing, advanced topics. This is mostly data structures. I guess data serialization, data structures. I don't want to get into how is a hash table created in C. No, no, that is not something I want right now. How do we create a sorted set, or how we do a binary, balanced binary tree? I think this thing is good enough. This thing is good enough because we have demystified sockets, first of all. Mm. And what are the good IO models for concurrency on a server? And we are now into event loop. So I guess, yeah, this would be it. This would be it. These three things. And advanced, this is like too low level. Even though I've written some assembly, this is still just seems, yeah, this seems manual labor. Writing hash table from scratch in C seems like manual labor. Oh, shit. Yeah, it is almost everything I feel. If I get a chance to do again, I'll do better because mindset changed a lot. I feel, yep, at my current, I will nail it. Yes, yes, mindset changes like real. While whether schooling or JE exam or college or anything, yes, mindset change is actually real because I guess it is the fear of fear. Yeah, fear of maybe not doing bad, fear of maybe doing fear of thinking of yourself that you are better than you actually are. And if you think of yourself that you are good or better, then you have to live up to that expectation of you being better. And that is a tough thing to do. Shit, that makes sense. That makes sense. If not defined, then define. That makes sense. That makes so much sense. We don't even need the header files, therefore. If n depth not defined connection, and this is how we do it, right? N small, if not depth connection, then def and if cool. We should not be getting any errors. Are you sure? Instructs.cpp. Save. Substitute every connection with capital C O and N. Included file redefinition of connection. That is just crazy. Uh-huh. No, if you have to explain the project to someone, how much time will it take? Like making a video or something? Explain this project, like from not fear. It's just I was not that interested in that time compared to now. I was doing it just for the sake of it. Shit. And if you are doing it better because you have interest, then interest is something that is not totally in your hands. It can still go away, right? And for me, it was fear, like unable to think of myself as like someone who can do something. And if I had to explain this project to someone, how much, like, explain in the sense of everything that I have learned from this, then I would say it would be much, explaining is much easier if The communication is two ways, full duplex communication. If the communication is full duplex, I can say, and the other person can also say things, then it is much better to explain, much easier to explain because the person is able to ask questions specifically. And that is why I like ChatGPT. You can just ask things specifically. Okay, this is why error? Why error? I don't get this. Redefinition of substitute con with capital C-O-N. And but why do we have a redefinition? Why do we have a redefinition? Okay, if not defined, then has defined con. That anonymous structure expected unqualified ID. What is that? Like for example, if not defined, then example if your struct uses a string, okay. Then struct define and if, and that is a comment. Anonymous structs and classes must be class members. Who is anonymous struct? No one is anonymous. Include struct define the structure. If not define this thing. Is this what they mean? Shit, shit. It does work. It works. Wait, no, there is some error. No, there is no error. That is nice. That is nice. Everything is working now. That is nice. Pretty cool. Uh, like making a video on this topic, what to do, how to do it, not like literally doing the whole project again. Okay, I think you should make a video or series on this project explaining what you did and all. It will help others well understand the project. Yes, that would be very nice. My explanation skills are not very good. I have to make them better. And before, yes, I have thought about this. And before delving into something, because this is not easy, this is like a bit complex. So I want to improve my explanation skills. And before making little videos, and yes, if I'm making explanation videos, I will not be streaming those videos though on spot. Those videos would be like full-length videos, like Veritasium or something. And I want to get some experience making those kind of videos before, and that is why I'm learning a few things. And when I am like a bit good, then I will start by making videos on simpler things. One thing that I want to make a video about is Euclid's algorithm for finding GCD of two numbers. That is the first topic on which I will make a video, and then I will take it up from there. Yeah, I have thought about this. Strategy. Yeah, Euclid's algorithm would be first. And yes, I'm learning some things to do this, to make this possible. And So we have written till now all the event loop side code, and this is very interesting. And even making a video would make, first of all, my explanation skills better, and also my skills for making video, if you call them skills, better, and also my understanding of the thing better. When you feel comfortable with it, yes, because I don't just want to push out a video. If there is a video on my channel, then my name is on that video. It is representing me. I want it to be as good as possible. I mean, with these streams, I don't have to be very refined, but with the videos, then I want to be refined and good as I can be. And okay, so we have written event side, uh, event loop code for the event loop, which is like, yeah, this thing is complex. Not complex, but yeah, this thing is tough. This is not beginner friendly, I would say, because this depends on a lot of interrelated topics. Event loop, like syscalls, blocking, non-blocking, concurrency, file descriptors, the fact that we are using file descriptors, and how we handle flagging here, this thing. Why are we taking and of these things here? That is flagging, like one way to use flags. And here we are taking or of numbers. That is a way to put on some flags. All of this is crazy. Yeah, just the number of things. There are a lot of things which are working together here to make this possible. And that is pretty nice. That is pretty cool. And I would say that would be it. Today is also a festival, so yeah, I have to like open the room so that other people can come into the room and do whatever they want to. Yeah, so that would be it for today. We have written event loop code. This is good. This is like, I feel very good after writing this. Yeah, and I think I can reproduce this if I do delete this whole thing. That is nice. That is nice. No, not easy. Just there are a lot of different things that are working together. I will have to see. I will have to see. But probably yes. Even if for 1 or 2 hours, probably yes. Yeah, that would be it. That would be it for today. We wrote code for event loop, and that is nice. Thank you for being here. Bye.